Hi, today we will talk about Spring Framework. Spring is one of the most popular frameworks right now being used for application development, but it's equally important to understand that what we can call it like the Spring way of thinking. That when we are doing Spring Framework, it's very important to understand and appreciate that what kind of problem the Spring Framework tries to solve and what is the way to think when you are building an application using Spring Framework. Okay, so I think the moment the Spring Framework comes into picture, we have heard this term called IOC, inversion of control. So let's take a step back and understand what does that means. What it means is that basically if we take an example of an hello world, in the good old days what you do is that you write your own main method in different languages in different way, but essentially it's like main and then you print the hello world here. Okay, and then what you do, you execute the program. Okay, what Spring says that you don't control the program, it's the other way around. The program will build the things for you and you just say that give me the service which can do a print, and you ask that service to so basically you get this service and ask it to print. Okay. So let's take a little different approach to understand these things. What we will do is we will look into the more important patterns that usually Spring follows, which will give an understanding that how basically Spring helps in evolving an application. Okay, so the first important thing that comes from Spring is the ability to create object. There is a corollary to that if you are doing any new in your application, basically if you are creating any object in your application, you are doing something wrong. You are not using the Spring the right way. There are still some objects which you will be creating like the transactional objects or the value objects, but especially the infrastructure layer objects, the services, that you should not be doing anew. So just for take an example, let's say that a very standard web app architecture is there is a DB, we write a DAO layer, we write the service layer, and we write the API layer. Okay, this is where usually the Spring would come and sit. Let's say that you have a, let's say, student object. So you might write a student DAO, you might write a student service, and you might write a student API. Okay. So from a Spring perspective, you should not be doing a new student DAO, you should not be doing a new student service, or you should not be doing a student API. Okay. So ideally, you should just have this class and you should just say @service, or you can do @repository and all those details. I will not skip those details, but essentially you say @service and the Spring will create the object for you. Very important. The Spring will take care of creating all your infrastructure. Okay, so that's where the inversion of control comes into picture. The control is all built here for you. It's taken care by Spring. You just need to know how to invoke those controls. You can consider them as levers also in the system. Okay, so this is what is about ability to create object. Again, remember this corollary: if you are doing new on any of these infrastructure level objects, you are doing something wrong. You are not using the Spring the right way. The other thing is ability to wire the relationships. Okay. So what does that mean? Now this service class would need the DAO class. So the DAO, because of @ repository, the DAO would get created by the Spring. Now, how do you give the handle of DAO to the service? Okay, so what you can do, you can probably, in the constructor of the student service, you can go and say that, okay, give me the DAO of the object. Okay, or while the Spring application comes up, the first thing you do is take this student service object, take this DAO object and build using a setter. No, that's where the second corollary comes up. If you are setting the infrastructure level objects, then you are again doing something wrong. The relationship should get wired. Only thing you have to do is resource of auto wired, and here you say student DAO. Okay. So see how this whole application, the infrastructure is evolving basically. It will take care of creating the object, it will take care of wiring the relationships. So this is two very fundamental notion of Spring. What you do is that take a step back, understand the whole model of your application, then go write the different classes for that one. Spring will take care of creating those objects, and Spring will take care of wiring the relationship between them. We just have to indicate that these two objects are related to each other. Okay. Then apart from this, there are a couple of more patterns which are useful while you are working with Spring. I'll just briefly touch them because they recur quite a lot along that application framework. The third thing is callback and template mechanism. A template pattern, I'm sure most of you would have heard about that one. A simple example is, for example, you want to open a database connection. So you have a database connection. So usually what happens is that you have a lot of boilerplate code to start the connection, get the session and things like that, and a lot of boilerplate code to clean up. Okay? And in between, essentially what you do is that you issue a query and you get the results which you want to process. Okay? So that's what the template mechanism does, template and callback mechanism does. The Spring will take care of this whole boilerplate code for you, and it will give you a hook to pass your query, and it will give you a callback which you can hook so that you can start processing the result. So essentially 2 points of interaction: passing your query and processing the callback. Okay, so any interacting with any third-party system, this is another very common recurring pattern you will see. Okay, then the fourth one is a proxy. So for example, you have a service which is located in a JNDI registry. It's a third-party service, and what you want to do, third-party service, okay, and you want to expose it to your application. You have your own service which is dependent on this. So what you do, you in basically third-party service, you basically use this proxy pattern. You basically implement one of these proxies that are available as part of integration, but essentially all the details like where the JNDI URL is located, if there are any authentication information and things like that, you pass to this one, and then this object is created for you, and in your other service you can just inject it like a third-party service. Okay. So this is how the proxy pattern works. Then the last one, the exporter. Exporter is like, for example, you have your service, but you want to expose it to a third-party world, third world. Then again, you can use the exporter one, and exporter will take care of basically hosting it in such a way that it will be available as a URL, as an API call to the third party URL. You just have to do certain configurations here and it will take care of. So just to recap, I think these are the 5 important things. Once you take care of that one, you'll actually start you'll develop a natural way of thinking in Spring. Just to recap, ability to create objects, ability to wire the relationships, callback and template mechanisms, proxies and exporters. Okay. Hopefully that gives an understanding to think in the Spring way. Thank you. Thank you very much.